So in this video we're going to go over how to find the length of a scaled vector. So the claim is that if we have a vector u and a scalar k, then if we want to know the size or the magnitude of k times u, we can just multiply the absolute value of k times the size or magnitude of the vector u. And you could verify this pretty easily. So if we're working with vectors in the plane, which is what has been the focus of this particular set of videos, then if we have the vector ku, we know that that looks like k times u sub 1, k times the first component of u, and then we distribute k into the second component of u. So if we want to know the length of k times u, the scaled vector, so if we want to know the size of that, we would take the square root of the sum of the squares of the components of that vector. So it'd be k times u sub 1 and then k times u sub 2. And then if we do a little simplifying, you would get k squared u sub 1 squared plus k squared u sub 2 squared. And then we could factor the k squared off on the inside. We'd get k squared times u sub 1 squared plus u sub 2 squared. And then we want to recognize that the square root of k squared is the absolute value of k. And then we would be left with, on the inside, u sub 1 squared plus u sub 2 squared. And we have to have the absolute value here. So, and this is why. Let's suppose the scalar is a -3. Well, if you square -3 and then take the square root, simplifying from the inside out, you get -3 squared is 9, and the square root of 9 is just 3. So if you accidentally just let square root cancel a squaring, if the number that's being squared is a negative, you get an incorrect result. So, and this will show up to bite people even in Calc 2 when solving, doing equation solving. So this is an important thing to note, that the square root of k squared, if k is a scalar, it has to be the absolute value of k. And then we want to recognize from a previous video, this right here is just how we defined the length of the vector u. If we have a vector whose length, a vector given by u sub 1, u sub 2, then its length is the square root of the sum of the squares of the vector components. So we wind up just getting absolute value of k times the size of the vector u. That verifies the result. And what we can do with this result is use it to simplify our life a little bit. So here I've got a vector 125 comma -100, and it says find the length or the magnitude of that vector. So I could just start grinding. I could say, hey, this is going to be 125 squared plus -100 squared, and I could start grinding this out. Or I could take advantage of the fact that it looks like a scalar has been distributed into this vector, and I can factor it back out. So this vector is the same as 25 times 5 is 125, and 25 times -4 is -100. So the size of this vector is just going to be 25, the absolute value of 25 is 25, times the size of the vector 5, -4, so I get 5 squared plus -4 squared. And now I've got a much simpler computation sitting under the radical sign than I did if I just blindly plugged the pieces in. So I get 25 times the square root of 25 plus 16, and that gives me 25 square root of, that's going to be, what, 41? That's a horrible 1 there. And then square root of 41 is already in simplest radical form, so we leave it. So anyways, we can use that property on the previous slide to simplify computations like this one.